Now, our next topic is meaning of binomial expansion. Any expression consisting of two terms connected by plus or minus sign, that is called binomial expression. So before seeing binomial expression, let us see binomial theorem. So what do you mean by binomial theorem? So binomial theorem, we can say that it is a quick way of expanding your binomial expression, that is whose power is given in large numbers. Suppose if it is given 1, 2 or 3, so we can easily expand it by these equations. But if the power are given more than that, 5, 6, 10, right? So this method, it will become very lengthy. So that time our binomial expression or binomial theorem comes into use. So without multiplying, and we get the answer over here. Now these are the few expansions, that is x plus a will be same x plus a raised to, so it will be 2x square plus 2xa plus a square, then x minus a raised to 2, so that will be x square minus 2xa plus a square, same way for the power of 3. Now what are the practical or real life uses of this binomial theorem or binomial expansion, we can say? So it is used in statistical and probability analysis. Then apart from it, it is also used in higher mathematics and calculation of binomial theorem. It is also used in finding the roots of equation in higher or with higher powers. And for weather forecast services also, we can say that it is used apart from it for ranking up the candidates. And if any engineering project or product is going on, so for estimating the cost for the same, we can use this, right? Now let us see our binomial expansion. Now the expansion of binomial x plus a with any positive power n, so that is known as binomial expansion. For example, x plus a raised to n, so that is equal to nc0 x raised to n a raised to 0, then nc1 x raised to n minus 1 and a raised to 1, then nc2 is equal to x raised to n minus 2 a raised to 2. Now as you can see here, as the power of x decreases by 1, then n minus 1, n minus 2, same way the power of a, it increases by 1, like a 0, then a raised to 1, then a raised to 2, right? So expansion of x plus a raised to n, this is called binomial expansion. And the general term which we use for this, the general term of this expansion is ncr x raised to n minus r into a raised to r. Now if r we are taking as 0, then our first term will be nc0 x raised to n minus 0 and a raised to 0. So our answer ultimately it will be x raised to n. If r I am taking it as 1, then next term will be nc1 x raised to n minus 1 and a raised to 1. Fine. Same way till whatever your n it is given, till nth term it will be. So my last term here will be a raised to n is equal to ncn x raised to n minus n a raised to n. Now characteristics of binomial expansion. First one, that is total number of terms in the expansion of x plus a raised to n is n plus 1. What do you mean by it? For example, here x plus a raised to your n power is say 5. Then the total terms when you will get for your binomial expansion, it will be 1 more than your n value. If it is 5, then 5 plus 1. So total 6 terms you will be getting in your binomial expansion. Second, that is the coefficient of the term of expansion are nc0, nc1, nc2 and ncn respectively. So these values we can directly get it from our Pascal triangle, which you will see just now. The next, the first term of the expansion is x raised to n, and in the successive terms of the expansion, the power of x goes on decreasing by 1 and the power of a, it goes on increasing by 1. So the last term of the expansion is a raised to n. The sum of powers of x and a is equal to n in any term of the expansion. Means any term, if we will see the total of the power of x and a, it will always be equal to your n value. The coefficients of the term equidistant from the middle term or terms are equal. Now the Pascal triangle, which was given by Blaise Pascal, who was a French mathematician. Now suppose if your n value is 1, so for expansion the terms you will be getting, that is 2, right? So my value or answer for the same will be 1. Then if my n is 2, then coefficients will be 1, 2, 1. Same way if my n is 3, then values will be 1, 3, 3, 1. It keeps on increasing by 1. Fine? And sum of coefficients, that is 2 raised to n. This we can easily find it out. Now let us take an example. Expand x plus y raised to 6. So here your n is 6, x is given x and a is given y, right? So my first term starting here, it will be nc0 x raised to 6 or x raised to n and y raised to 0. Then from next term onwards, here also like 61, then 62, and from x my 1 will decrease, like here it is x raised to 6, in next it will be x raised to 5, third term it will be x raised to 4, and for this y value it will be increased or plus 1 it will be there, like y raised to 0, so here it will be y raised to 1, then here it will be y raised to 2. Fine. So this value like 60, 61, 62, we can easily get it from our this Pascal's triangle. So for binomial expression, some important results which we have to remember, that is the general term is NCR, x raised to n minus r and a raised to r. Now if n is even, then middle term of the expansion x plus a raised to n is obtained by putting r is equal to n by 2 in our general term. And if your n value is odd, then two middle terms of the expansion of x plus a raised to n we can obtain by putting r is equal to n minus 1 by 2 and n plus 1 by 2 in our general term. Exercise 6.3. First question, obtain the expression of the following binomial expressions. First one, 3a plus 4b raised to 3. So here 3a, this is your x, 4b, this is your a, and 3, this is your n. So general term we are knowing of our x plus a raised to n value, right? So we'll expand, that is nc0. So what is my n? 3. So I'll write down here 3c0 and c0 x raised to n and a raised to 0. So 3c0 x value is 3a raised to 3 and 4b raised to 0. Then here plus after 3c0 now 3c1 3a raised to, now the value or the power of your x value will keep on decreasing by 1 and power of your a it will increase by 1. So 3a raised to 2 and 4b raised to 1 plus 3c2 3a raised to 3 and 4b raised to 2 plus 3c raised to 3c2 then 3a raised to 4 and 4b raised to 3. So as you can see that the total terms which you are getting, it is one more than your n is 3. So n plus 1, that is total terms which you will be getting is 4. So that is equal to 3c0, it is 1. Now 3a raised to 3. So multiply here 3 into 3 into 3. So you will get here 27a cube and 4b raised to 0. So that is 1 plus 3c1 is 3 into 3a raised to 2. So 3 into 3, that is 9a square into 4b raised to 1. So 4b plus 3c2. So 3c2 again it is 3 into 3a raised to 3. This is 3a raised to 1 and this is 3a raised to 0. It decreases by 1, that is 3, 2, 1 and 0, and here 0, 1, 2, 3. So 3a raised to 1, it will be 3a into 4b raised to 2, so that will be 4 into 4, 16b square plus 3c3 is 1 into 3a raised to 0, so it will be 1 into 4b raised to 13. So 4 into 4 into 4, that will be 64b cube. Now here when we multiply first term, so that is 27a cube plus 3 into 9 into 4, so that is 108 and a square b plus 3 into 3 into 16, that is 144 a b square plus 1 into 1 into 64 b cube. So that is your answer. Second question, there is 1 plus x raised to 7. So n is 7, x and a. So we'll start with the sum, that is equal to nc0, that is 7c0 x raised to n and a raised to 0 plus 7c1 1 raised to 6 and x raised to 1. Here the power of x will decrease by 1 in each step and power of a here, that is second term, it will increase by 1 in each step. So 7c1 then 7c2 1 raised to 5 x raised to 2 plus 7c3 1 raised to 4 x raised to 3, and the total of this powers, it will always be equal to your n, that is 7 any step. So 7c4 1 raised to 5 x raised to 4, here it will be 3 and here it will be 4, then plus 7c5 1 raised to 2 and x raised to 5 plus 7c6 1 raised to 1 and x raised to 6 plus 7c7 1 raised to 0 and x raised to 7. So here it will be in decreasing order like 7, 6, 5, 4, 3, 2, 1, 0, and here it will be in increasing order 0, 1, 2, 3, 4, 5, 6, 7. Now these values you can find it out by putting combination formula, but better easy than that you remember Pascal triangle, so directly you will get these values. See, now my n is 7, so what is the respective coefficient values of that? That is 1, 7, 21, 35, 35, 21, 7, 1. So that thing directly I can write it down without calculation, right? So 1, 7, 21, 35, 35, 21, 7, 1. Now here this n is 7, so values I know now, so I'll write down directly, or you can write down here also, same way here also you can write it down. 1, 7, 21, 35, 35, 21, 7, 1. Now solve this. 1 raised to 7, 1 raised to any power, answer will always be 1, right? So you can directly also write down multiply by 1 everywhere. And then the last step, that is x raised to 0, that is 1, x raised to 1 is x raised to 2 is x square, then x raised to 3, x raised to 4, the power increases by 1, so x raised to 3, x raised to 4, x raised to 5, x raised to 6 and x raised to 7. Now directly we will get our answer. So first term here it will be 1 plus 7 into x, so 7x plus 21 into x square, so 21x square plus 35 into x cube, so 35x cube plus again 35 x raised to 4, 21 x raised to 5 plus 7x raised to 6 and plus x raised to 7. So here this will be my answer.